This is a question from GATE 2016 from Chemical Engineering, question number 49. A porous pellet with platinum dispersed in it is used to carry out a catalytic reaction. Following two scenarios are possible. Scenario 1, platinum present throughout the pores of the pellet is used for catalyzing the reaction. Scenario 2, platinum present only in the immediate vicinity of the external surface of the pellet is used for catalyzing the reaction. At a large value of Thiele modulus, which one of the following statements is true? A. Since the reaction rate is much greater than the diffusion rate, scenario 1 occurs. B. Since the reaction rate is much greater than the diffusion rate, scenario 2 occurs. C. Since the reaction rate is much lower than the diffusion rate, scenario 1 occurs. And D. Since the reaction rate is much lower than the diffusion rate, scenario 2 occurs. So this is a question from Chemical Reaction Engineering 2 from catalysis part, and the reference NPTEL series can be found in lecture 9, Introduction to Intraparticle Diffusion, Chemical Reaction Engineering 2 by Professor Sanjay M. Mahajani, Professor Ganesh A. Vishwanathan and Professor A.K. Suresh from Department of Chemical Engineering, IIT Bombay. So here there are two scenarios given here. So let's say this is our pore or active site on the catalyst. So you have a particle. So the first two steps in catalysis is that this particle from the bulk has to first diffuse externally to reach the external surface of the catalyst. So this is called as external diffusion. Then your particle has to diffuse into the pore or the active site of your catalyst, and that is called as internal diffusion. And then your particle has to get adsorbed, then react and desorb after forming the products. So these are the various steps that are happening in a catalytic reaction. So here one data that they have given is that the value of the Thiele modulus is very large. So by this we can say, Thiele modulus is defined as the ratio or the root of ratio of the surface reaction rate by internal diffusion rate. So if Thiele modulus is very large, that means your internal diffusion rate is very low. Or in other words, this system is basically controlled by internal diffusion rate, or internal diffusion is rate controlling. Right. So here your particle externally diffuses to the surface. So let's say you have multiple particles. These particles will first diffuse to the external surface, and then from here they have to diffuse internally to the catalyst activation site. And this step, this internal diffusion, is very slow. But after diffusing, when the reaction happens, that is a very, very fast step. Okay, so what happens basically is, so your particles are right now, let's say, on the external surface, and let's say one by one they are diffusing into the internal surface very slowly. The moment they get adsorbed on the catalyst side, reaction happens because the reaction rate is very fast. So the moment this your reactant particle gets adsorbed on the active site of your catalyst, reaction will happen very fast, and because of this, this particle will basically just vanish immediately. So when an observer looks from the outside, they won't see this particle here. Rather, they'll be looking at the particles which are on the external surface of the catalyst. So that means when an observer looks, there will be only particles on the external surface. There will be nothing inside the active site, because whatever is getting adsorbed into the active site is reacting very fast because the reaction rate is very high. So this is basically equivalent to your scenario 2, where the platinum or the particle which is platinum here is present only in the immediate vicinity. This immediate vicinity is basically the catalyst surface just outside the active site. So the platinum is present only in the immediate vicinity of the external surface of the pellet used for the catalyzing the reaction. So scenario 2 will happen here because of the large value of the Thiele modulus. And because the Thiele modulus is very large, your internal diffusion is rate limiting. So that means your reaction rate is much greater than the internal diffusion rate. So putting together everything, option B will be the right choice here, because as the Thiele modulus is very high, your reaction rate is much greater than the diffusion rate, and because of the explanation that I just mentioned, the platinum will be found only in the immediate vicinity of the external surface of the pellet. So your right option here is option B. Since the reaction rate is much greater than the diffusion rate, scenario 2 occurs.